Morning, ladies and gentlemen. This is Mr. Rowe. We're looking in Geometry Part B. This is Lesson 14, and we're looking at inscribed angles. So real quickly, an inscribed angle has its vertex on a circle, and its sides contains chords in the circle. So this is a completely inside the circle angle with all 3 points on the circle. So this is an inscribed angle, angle ABC. So inscribed angles theorem says that the measure of the inscribed angle is half the measures of its intercepted arc. So the arc that it has endpoints on, the measure of this arc is half the measure of that angle. So the measure of angle B is half the measure of arc AC. So here's an example. So remember, we want to distinguish between central angle, which has its endpoint on, or its vertex in the center, versus an inscribed angle, which has its vertex on the circle. So this arc right here, remember, is the same as the angle. So the central angle and that arc are the same. So BD and Q are the same. We want to find the measure of angle A. The measure of angle A equals half the measure of arc BD. Well, what's the relationship between arc BD and angle Q? They're the same. So if we substitute, then the measure of angle A would be half of that 128-degree angle. So it's 64 degrees. All right, so there's some corollaries to this theorem. Here's the first one. First one says that two inscribed angles that intercept the same arc are congruent. So here is a picture of this situation. You see we have angle A and angle B right here, and they have endpoints right here at C and D, and that's the same arc. All right, so see angle A and angle D intercept arc CD. So then angle A equals angle B, or is congruent to. So here's an example. So again, we've got some situations here. We got angles A and angle B. They both intersect angles or arc CD right here. So that means they're going to be congruent, and they equal half of arc CD. Well, what's arc CD? It equals the central angle. So since the central angle is 70, then CD is 70, and so angles A and angle B would be half of that, which is 35 degrees. Okay, here's a second corollary. An inscribed angle in a semicircle is always a right angle. Now this one is it's kind of self-evident when you look at it, but if you have an arc that has its endpoints on the diameter, which is a better way to say this. So endpoints on the diameter, and then the vertex somewhere on the circle, wherever that angle is going to be a right angle. So in this case, BC is a diameter, segment BC. And since the measure of arc BC is 180 degrees, then angle A is 90. So here's the third corollary. Now you have a similar example to this in the lesson, but we didn't have this corollary before we talked about it. So we're going to apply this corollary to a similar problem. So the opposite angles of an inscribed quadrilateral are supplementary. So here's the quadrilateral. So basically what this says is that the angles across from each other have to equal 180 degrees. So B and D have to add up to equal 180. A and C have to equal 180. And here's what that says. So A plus C equals 180. B plus D equals 180. So here's an example, and I put some numbers in there this time. We've got angle E is 76 and angle H is 98. Well, to find angle G, G is related to E. So the measure of angle G would equal 180 minus 76 because the two have to be supplementary. So 180 minus 76 is 104 degrees. And then F, measure of angle F, is related to the measure of angle H. So we have to subtract 180 from the measure of angle H, which is 98 degrees. That gives us 82 degrees. And that's similar to one of the examples we had before we actually wrote the inscribed angles theorem. And then finally, we're going to look at theorem 14.2. It says that the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So basically, here's what this looks like. We've got a chord, and then we have a tangent. So we talked about tangent in the previous lesson. Remember, tangent intersects the circle at one point. So the angle that's formed right here is half of this arc right here. So whatever this arc is, divide it by 2, and you'll get this angle. So the measure of angle ACD is half of arc ABC. I could have just said AC, but I wanted to make sure you understood that I wanted to go in this direction. All right, so here's an example. Measure of arc BA, which is this arc right here, is 102 degrees. So what is the measure of ABC? It's half of 102 degrees, which is 51 degrees. So I hope this helps you with your assignment on inscribed angles. I hope this helps you introduce the concept and helps you understand it a little better. If you're still struggling with this concept as you're working on your assignment, please let me know in a teacher message. An appointment for a help session.